Let's take our next question, that is question number 22. Now the question you see here belongs to section of heat and thermodynamics from the chapter kinetic theory of gases. An HCl molecule has rotational, translational and vibrational motions. If the RMS velocity of HCl molecule in its gaseous phase is V, m is the mass and kb is the Boltzmann constant, then its temperature will be. So it's a very simple relation given here. So let's start with solution. So V RMS is given by the relation 3 kBT by m, right? So from here you can write that T is equals to mV. So this is given as V bar. So V bar square by 3 kb, right? Let's see which is the best suited option here among the 4 options given to us. Option number 4 would be the right answer. Now let's move on to the next question, that is question number 23. Now the question you see here belongs to section of electromagnetism from the chapter electrostatics. A system of 3 charges are placed as shown in the figure. So this is a dipole basically, and the capital Q is placed here. We need to find the potential energy of this system where capital D is too much greater than small d. So 1 is the potential energy of this dipole in itself, and 1 is the potential energy due to this dipole on this Q. So let's solve that. So on solution, potential energy first due to the charges of dipole itself will be this, then plus the potential energy due to dipole on the capital Q would be Q into V, and we are all aware that potential due to dipole at any point on the axis would be given by K P upon P is the dipole moment, D square, and that is negative. So when you put this dipole moment as QD, you will get small qd divided by d square. So now when you put down this in the formula, you will get minus K q square by small d minus K small q capital QD upon capital D square. Let's see which is the best suited option here. Among the 4 options given to us, option number 1 would be the right answer. Now let's move on with our next question. Now the question you see belongs to section of electromagnetism from the chapter magnetic effects of current. As per the question, there is a rigid square loop of side A which is carrying current I2, and it is placed in a horizontal surface near this long current carrying conductor which is having current I1. We need to find the force on this loop due to this conductor, right? So what is the magnetic field due to this conductor? It is inside in this plane. So now this will apply force on all the 4 loops. For this loop, if you see, the force will be acting downwards, and similarly for this the force will be acting upwards, and they will of equal magnitude, so they will cancel out each other, right? Now we are left with these 2. So for this conductor the force will be along this direction, that is repulsive force due to this one, and for this it is inwards. Now we need to find the values of these forces. So the net force will be simply F1 minus F2. Now what would be the value of F1? So if you want to find the value of F1, it is F1 can be written as B1 into I2 into the length of the conductor. What is the value of B1? So mu naught upon 4 pi twice of I1 by A into I2 into A. So on solving this you will get mu naught upon 4 pi. From here this is 2I1 I2, right? This is F1. Let's take this as first equation. Similarly, when you write F2, that would be B2 into I2 into length of that conductor. This is mu naught upon 4 pi 2I1 by 2A, because the distance has increased, and into I2 into A. So when you solve this, you will get mu naught upon 4 pi I1 I2. This is the second equation. So from here simple F net would be equal to F1 minus F2. When you put the values, you will get mu naught upon 4 pi I1 I2. And this force would be repulsive because the F1 was a repulsive force. So let's see which is the best suited option. Among the 4 options given to us, yes, option number 1 would be the correct answer to this question. Now let's move on to our next question, that is question number 25.